Welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual for January 27th, 2026. Tonight we will do our normal roundtable discussion presentations, and after that we'll open it up to any questions, comments, stump the club type stuff. Just as a side note, somewhere I have a note. Housekeeping, I just want to announce the results of the election. The election was as per the board's recommendation. And if I can find the listing. So president is Mark Reynolds, vice president Paul Boucher, secretary Doug Parody, treasurer Steve Edwards, and IT officer Pat Caron, myself. So that was the results of the election. They had a total of 34 members, I believe, paid up. 15 people voted, and so it was 43% participation. So overall, I guess, all right. I'll find out what I'm in for, being volunteered for IT officer. We'll see what happens. I don't think it's a crucial role. I think it's just help support.
You were conscripted, huh?
I was asked if I would consider running, and I said yeah.
Yeah, they said that you have to speed it up somehow.
I have to speed it up?
Yeah, speed up the website.
No, that's not the type of thing the IT officer does.
Oh,
we have a secretary, Doug Parody, that does a lot of the website stuff. So as IT officer, I'm looking after our internet tools. So our YouTube subscriptions, our Facebook subscriptions, our Google drives, all of that to help monitor and make sure that nothing lapses and everything carries on. So it's all sorts of subscription stuff, and making sure that no due dates go past without renewing something, and whatever else they do. I seem to have inherited meetings, so we'll continue doing meetings.
yeah, it sounds like IT. Yeah.
First up for presenters tonight, we got Mike. He's got a short presentation for us.
Oh. So I dusted off my robot, took it out of the box from last year's 6-can, and repositioned the sensors and rearranged the boards. The whole idea was to use the lidar to detect both the cans and to do the localization by seeing the walls. Last year I had the lidar above the cans, so it only did localization. And so bringing it down to see the cans on the field, I could take a couple sensors off because it would take the place of some of the sensors that's supposed to see the cans, like the distance of the cans and obstacles and stuff. So the software part of it's going to be interesting because I'm going to send the entire lidar scan to the AMCL for localization, but notch out where I think where a can is that I'm trying to approach and grab, so it doesn't think it's an obstacle. So that's my big change on it, and I'll show you the robot. So it looks like last year's. It's like a Roomba. It's about the size of a Roomba. It's like amazing. And the trick is I made it a lot thinner. Let me pull out that support for the last. Oh, all right, took the trash out already. Well, the lidar was a lot taller than that. So I had to redesign some stuff. Like I had to lower the camera down because it was blocking the lidar and stuff. And I've and I rearranged all the modules on it, and I attached the modem to the back. Last year I didn't plan on having the modem router, and I put it on the front, and it unbalanced the weight, and it wasn't stable enough anymore. Like it would teeter-totter a lot. So now I put that back on the back and kept the front lighter. So and then on the bottom, it has the let's see, hold it with this hand.
Battery.
So here's the battery, and this is the caster here. Of course, motor and wheels, and these are the grabbers. So they come up and grab the cam. And I redesigned this. I put a switch in the center here. So when the can is grabbed, it sets the switch. And I designed this catch on here so that the can is stable. So when it pushes, it doesn't twist and turn. Last year, I didn't have it. I just had the thin plywood edge, and it would sort of try to go under the robot. And when I was pushing it. So I think this year is going to be a lot better. I still kept the on the front. I still kept the two eyeballs here, which are dual 8x8 time of flight sensors, and they see around. Like when the can is grabbed, they don't see it, so they basically point out, and they act as like obstacles when a can is grabbed, and so it can see in front of the can. Like the lidar here wouldn't see in front of the can because it gets blocked. And it's also obstacle detection. Like if the can has fallen on the field, it'll still see it when it gets close enough, because these will see the cans on the field instead of standing up. So, and this is the power supply here. Hold it. So the power module is here. So it has 3 power supplies: a 12-volt for the motors, a 5-volt for the Pi, and a 5-volt for all of the peripherals. And I power the peripherals through a powered hub. The powered hub plugs into the Pi and powers the peripherals. So last year I was putting power jacks on all the peripheral modules, but for my Robo Columbus robot, I just powered it all with USB, and I liked it better because less wires. so I said I'm going to not going to put those wires on, and I'll just power it through the powered USB. Like last year was more of a okay. So I got pointed the modules here. So this module here is the motor controller, and this module up here is the sensor controller, and of course the Pi. So I have 2 boards on here, one for the motors and one for the sensors. And the motor controller also controls the grabbers, since it's a motor. So yeah. So I think I lined up the camera and the lidar so they'll point at the can properly. I got to tune in this is a laser right here from last year. I put it on the bottom so that I could, because I was lowering everything and there was no room for it on the top. The camera couldn't see over it, so I put it on the bottom. And
what's the laser for?
For pointing, like for quick trip and stuff, to get a good straight point. So I still have to calibrate it so that it points to the center of, the center of the camera and the center of the lidar, so everything's all lined up properly. And got to make sure everything goes straight when the wheels are turning. So I guess that's important. So I got a lot of calibration to do to make sure if I'm having it go straight, I want it to go straight and then get the the laser in there and then calibrate the camera and the lidar to point to wherever the straight is, straight ahead. So that's my show and tell. I got
It's good for
calibration
messing
to
with
do.
your competitor's vision, just
Blinding the other people's cameras.
Yeah.
Well, that's good. Thanks, Mike. Any questions for Mike? Okay, next up we got Ted.
All right. Yeah, I just have kind of an update on my robot and the sensors. So I think I have something like 8 I2C devices on a Teensy, and I was having some trouble with, I think I hooked up the GPS as an I2C, and it wouldn't respond when I had some other stuff. So I started unplugging things and found out it was my lidar light that was causing issues. So I don't know why. Haven't quite figured that out. I checked that, make sure all the addresses were unique, and they were. But what I ended up doing, and it was kind of interesting, is it turns out the Teensy has 3 I2C ports. And so I moved the lidar light to one of the other I2C ports, and that cleared things up. But it turns out none of the software libraries are written to support ports other than the default port. And so fortunately, the lidar light library is fairly simple. So I just went in and made a copy of it and changed all the I2Cs to the second port, and that worked. I'm a little concerned that if I ever get an update, then obviously it won't update my copied version, but I'll deal with that when it happens. Yeah, that's all I had.
Ted, I2C, of course, needs pull-up resistors. And I'm just wondering whether you've experimented with the value, the net value of the I2C pull-up resistors you've got on your various I2C buses to see if that makes any difference. A lot of sensor modules will have their own resistors as well.
Right. And I thought about that, and it seemed like a lot of work, and this was the easiest thing. So yeah, you're probably right. Thinking about it again, it was probably something to do with the pull-up resistors. Yeah.
I do like that Teensy having 3 different I2C ports off of that thing.
Yeah.
I've been known to take advantage of that.
Yeah. I was kind of disappointed that I couldn't just set anything in the libraries to change, but I think I looked through all my libraries, and none of the devices I had supported any other ports than the default port, but at least most Arduino code has, you got the source code you can play with if you need to.
Did you make a fork and make it programmable so that you can send it back to the maintainer?
Yeah, I thought about doing that, but I ended up thinking, oh, it's easier just to make a second library that only uses the second port.
Right.
Yeah, sometimes I've even gone to the extent of saying, okay, this is a simple library. It's now becoming inline code in my program.
Yeah, there's that too.
Now it's only mine. And it won't get lost.
Or change suddenly out from under you.
Yeah, I've done that with libraries, is move them in Platform IO into the source folder. And so any modifications I make don't get overwritten by the package maintainers.
Yeah, I've made that mistake before where I just used the library, and then when I updated it, I lost all my changes.
And when I do that, I usually remove much of the generalization that the developer very wisely put in.
Yeah.
So it's not there anymore. It ain't general.
It makes it simpler. Yeah.
Usually that's why it's in my source folder and not in the library folder. That's interesting, Ted. I'd be curious to see that if you put pull-up resistors, as Tom had said, is it possible that your lidar light would start working?
Yeah, possibly. I've got some already soldered in there, and I didn't want to have to go get out my soldering iron and start working on the hardware. So I decided software was easier.
Well, if you got everything plugged in, you can turn the power off and put your own meter on the pull-up resistor values and see what the net effect is of all the devices on the bus.
Oh yeah, probably could
Pretty
do that.
easy.
Mhm.
You know, I've seen that a time or two in the past where I got an I2C board, now I'll do the air quotes on the I2C, because yeah, it took that protocol. But if you put anything else other than that thing on the bus, it just totally obliterates everything. And the way it's I2C, but it's not I2C and plays well with other I2C. It's just like it assumes it's the only thing on that I2C port, which, you know, it's a piece of firmware on the board. Not a lot you can do about that. So,
Yeah.
of course, you find that out just after you wish you knew it, right?
You find that out 10 minutes after the contest started.
Uh-huh.
Mhm.
Yeah. And of course, if you have a scope, if you can put a scope on the bus, you'll see what's happening right away.
Oh yeah. Good point.
Well, thanks, Ted.
Yep.
Up next, we have Ray. Ray, are you ready?
Yep. Can you hear me?
Yes, we can.
Okay, good. Window. That's not the window I want to share.
I pinned your phone video.
Oh, okay, thank you. Entire screen. Share. Okay, pictures open. All right. Where is it? Okay, can you see the numbers flying by here?
Mm-hmm.
Okay, so that is actually the angle that I need to rotate to get this array of sensors to line up or be like the midpoint between two beacons. So the two beacons are similar except for one looks at or tries to find a 400 microsecond pulse from an RF transmitter. So these each have, what am I pointing at there? Oh yeah, there it is. These each have an RF receiver. It's 433 megahertz, and they also have an infrared emitter on each one. So right. Let's see if I can point it right there. Anyway, so the kind of the way this works is this will be on the robot. It'll send out an RF pulse. The first one is 400 microseconds. The beacon 0, which is that one over there, tries to detect that. And if it finds it or receives it, it sends out a burst of infrared 1 millisecond on, 1 millisecond off at 38 kilohertz. And then all of these little receivers, I don't know if you can see them in there, receive basically a 2 pulses of 38 kilohertz at 1 millisecond, and basically figures out the average actually the mean of which of those receivers on the robot saw the beam. And there's like fins on this thing around. So it's, if it's not hitting it directly, the sensors are shielded. So it may hit maybe 2 or at most 3 sensors, depending on how close it is to the 2 transmitters. Anyway, so right now it is saying I've got to move -5 degrees. Let's see, I think negative is, nope, negative is counterclockwise. So, okay, so that's kind of fluttering around 0. And this little arrow now, I don't know if it's going to be easy to see, should point, and it looks like it does, between that beacon and that beacon. So it looks like it's pretty much dissecting the 2. So it's like roughly right here, which is about in between the 2. So, and it turns based on the minimum amount of turning that it should have to do, because you don't want it, if it can rotate 5 degrees to get in position, you don't want it rotating 355 degrees to get all the way back to that point. So anyway, so I checked it out upstairs with the an actual course layout, and I thought my transmitters were a little on the weak side at the 10-foot mark all the way back, and I'm only using 1 diode on the infrared transmitters on the beacons, and I wanted to actually use 3 so I can cover 90 degrees, because they're they say they're plus or minus 45 degrees, but that falls off pretty quickly the further you get around that. So right now I just have them pointing at 45 degrees, but I don't think that's going to be enough, and I think I need to add 2 more to point basically at 0, 45, and 90 degrees to cover the whole course. Anyway, so I used Copilot, or asked for Copilot's help. Basically, wrote a list of requirements, even included pin assignments for which sensor was wired to which microprocessor pin, all that kind of stuff. So it some of the other ones, the routines before I kind of got all my thoughts gathered, really weren't that good. It's hard to say, was that more me or was that more Copilot? And some of the schemes that it gave me were really way too complicated. I just wanted to find basically the midpoint between the 2 beacons, because that's the center where the goal is. And that seems to be doing that now. So anyway, it's pretty cheap. It's fast enough. In 20 microseconds, I can do 2 readings, or read, each beacon. And my update rate on the motors is actually 50 milliseconds. Sorry, not microseconds. So it's plenty of time. I can do it pretty much for every motor update or every motor update cycle. So I do need to add a little filtering, like if I put this on the plotter, you can see it does bounce around quite a bit, and it really, I think I'm blocking part of the beam there, but actually the scale there, that's like, half a degree per division. So it, looks like it's kind of bouncing around -1 right now, but occasionally go down to -3.5. So I think if I add additional filtering, that should smooth that out. maybe do a moving average of either 2 or 3 values.
Mhm.
Anyway, so for the number of sensors, I only have 18. They're every 20 degrees apart. So after the robot gets the can, it's the light is always pulsing on the robot. So all it has to do is quickly look, for both beacons, and once it finds it, it can establish where, what angles those 2 beacons are basically shining on the robot, and then find the mid angle, and that's how I need to, or that's the amount of turning that I need to do to get to the center of the goal. So, and this is one of those bucket list items. I always wanted to explore this, so finally got the time to do it.
So if it's pointing backwards, does it know to rotate 180?
Yeah. Like if I point this backwards now, it'll rotate the smaller of the 2 angles.
Mm-hmm.
So yeah, right now it's at 155 or so. Okay, so 170. Okay, 180, and then it should flip over to negative. Yeah. So 175 is actually less rotation than going 185. So it chose the lesser of the 2, which is what you want it to do. It's kind of arbitrary if it's at, exactly at 180, because it'll rotate, and it is getting some really wild values there, switching from 150 to close to minus 150, but it's probably right on the edge of, yeah. Anyway, so it seems to work pretty good.
It'll find the goal. It's the goal area, so that's good.
Yeah, that's all it needs to do. I don't need to mess around with a compass. Use QR codes or not QR codes, April tags or anything else to basically find the center of the goal.
Does it tell you any distance?
Does it tell you what?
Like distance to the goal or anything? Any distance? No. Okay.
I think I could figure that out. Yeah, at this point, I just wanted it to, point towards the center of the goal, regardless of where it was on the course and what its orientation was, what angle it was currently facing. So
awesome.
That kind of solves both of those. I think I may need a third beacon, at least a third beacon, to do distance, but I'm not sure. So I think, I don't know. I'd have to look into that.
Ray, I'm impressed that what you put together seems to be working very, very well from a practical point of view. Congratulations.
Oh, thank you. Yeah, it's like I said, I've always kind of wanted to play around with this concept, and actually 3D printed that thing, I don't know, several months ago, and it kind of sat on my desk for a while. And it's, I did it all with wire wrap wire, and it's, and basically glued each sensor into that housing. And, it's a pretty simple sensor. It's just got, VCC ground and out. And so, had to wire all 18 of them together into the processor. So it, it seems to be working pretty good. I was thinking of putting, right now I have the processor underneath it, and all the wiring comes down to it. I was thinking of actually putting the processor on top, because then all the wires would go up underneath and like just through some holes that are big enough to, let the wires through. And so basically all I need is power ground, and it'll have a serial outline, which will go to another processor. So it's pretty much contained or self-contained once you power it up. So
I find it pretty interesting that you can get better than 20-degree resolution when you have a sensor every 20 degrees. So.
Well, yeah, because it's hitting, definitely at least one, but more likely 2 or 3. And so you can take the mean of that, based on the number of sensor hits. And, there's an array that counts all the sensor hits for each scan. And so you can, figure out a mean angle based on that. And so I'm not certain what I thought Copilot said you might be able to get like 5 degrees, plus or minus 5 degrees, because there are so few sensors. There's only 18,
Mm-hmm.
So you could probably get better resolution if you had more, but it's not like I need, I mean, these are printing out in floating point, two places. It's like,
Mm-hmm.
that's pretty much useless information. It's, should have been in integer, but, yeah, so I think I prefer not to scale it before it's sent, because that you can lose a little bit of resolution that way. But I definitely want to add some filtering because it can bounce around. Anyway, so that was all I had. I'm going to sign off. If I can figure out how on my phone.
Yeah, it's looking like they're getting isolated errors or offsets.
Yeah, it's right now. Yeah, it's jumping around. I think I'm partially in the way of one of the sensors.
Mm-hmm.
Like if I get my shoulder out of the way, it seems to, and it's bouncing around to like 170 to 166, 173. So, yeah, that may be, at this point, I know my emitters, infrared emitters are a little too on the, a little on the weak side. I need to add more. And so it kind of covers the whole course area.
You could run them at 12 volts.
Yeah, make them glow. No. Okay, I'm going to try to get out of this. God. Okay, there we go. Okay. Hang on, I'm on my phone.
So Ray, do you have a 5-volt system you're working with, or are you doing 3.3 volts as your main power? Oh, he's off for a second.
He's muted.
Yeah. Oh, he's muted. Your mic's muted, Ray. He just hasn't landed back.
Turn that off. Okay, back to normal.
Yeah, I was wondering, is your system a 5-volt system as your everything runs at 5 volts or 3.3 volts?
The transmitter in the robot, you can't run it at 5. It's got to be 3.3. So I actually have a little, 5 to 3.3 converter on that board. If I went to, I was thinking of using an ESP32 to do it, then I wouldn't have to have, the extra step down converter, I could run it on the 3.3 for everything. I might have to fool around with like resistor values on the infrared transmitters to get, if I drop the voltage down to 3.3, they'll work at that. But it's going to be for the same resistance, it's going to be less power. So right now, let's see, the current on the robot is only 27 milliamps. So it's, that's the other thing. It's pretty low power.
Mhm.
The beacons, I haven't actually stuck the USB meter in that. I'm not certain what they're drawing, but I'm assuming it's about the same. They're not doing that much, and it's, it's not like it's, doing all kinds of math and switching things on and off. It's, but so it's, I guess that's the other thing too. I mean, lidars are pretty power hungry. Just not having a high current requirement seemed like a good feature too. So anyway, so that was all I had.
Oh,
Well, that's
very
pretty
nice.
good, right? I marked down a black star for significant progress. You showed some good results. It
Yeah.
looks possibly promising for triangulation if you can get a couple of transmitters on the arena,
Yep.
and you'll be able to figure out where your robot is, which way it's facing.
Yep. Be able to get rid of a compass and, open CV stuff where you have to detect, different things, either different, color blobs or other things. So the fact that it was fast, low power, seemed all pretty good. So watch Scott will come with, a high powered TV remote, pointing it at that.
You're giving him ideas. He's going to watch the video and figure it
Oh
out.
God. You can you edit that out? So yeah.
Okay. Well, that was the end of our presenters. I don't know if anyone has any questions they want to ask. Ideas, problems, something we can help you with. It's quiet. How about you, Kareem? I see you've joined. Anything to present tonight?
Just lurking.
Just lurking. Okay.
Congrats to all the board members who joined up recently.
Thanks, Kareem.
We do appreciate the work. Really, we do.
I
Are
don't
you
think
the only one on right now?
I am the only one on right now. Yes.
Oh.
Yeah, where's the pres and the VP? I mean, they goofing off somewhere.
The VP is in the Maldives. I had to look that up on Google Maps.
Oh wow.
And I don't know where Mark is tonight. Usually he joins. Usually Doug joins.
Mhm.
I don't know if I've ever seen Steve. Maybe on at the Robo Columbus on the video. That's it.
Yep.
I don't know if Steve, if you do watch the videos, maybe you can answer my email from this week.
Say, please don't ignore me.
I think I just go straight to a spam folder.
Yeah, when I was doing my power on my robot here, when I was powering it up, I was noticing one module wasn't getting power to the peripherals out of the microprocessor. I mean the micro, yeah. And I, like, it's a a little module, and one of the pins is 5 volts, which is supposed to be the 5 volts from the USB. And then I touched that pin. I mean, I can show you the. Like this is the processor module here. And so that the pin at the very top is the 5 volt pin. And and then I was sort of probing around with a voltmeter trying to figure out what's going on. And when I pressed on that pin, the power came onto the peripherals, the time of flight sensors.
Uh-oh.
And
Old solder joint.
yes, because I looked at it and it looks good. I mean, it looks shiny and everything. But I took the soldering iron and touched it up, and it seems to work now. So I was shocked.
Yeah, I actually had a pin. It was basically I had solder on the pin. The pin was just sitting in the center of the hole, not making contact to any pads. So I had a little blot of solder on the tip of the pin and nothing else. And it's like, oh no, do I have a bad module? And it's like, nope, it's good, you know?
Yeah.
And then I noticed on one of the other processors, I had actually shorted 2 pins together. So I wasn't using them. They're all, you know, they were left as inputs. But, you know, I thought, God, my soldering technique's gone to hell in a handbasket or something, you know. Got cold solder joints and, you know, bridges and so.
Opens and yeah.
Yeah. So.
Yeah, because it looked like that solder joint looks like it was whipped from the pad up to the pin and everything. I looked under the magnifying glass and said,
Nope.
What's going on here? Looks good.
I've noticed as I get older, my magnifying glasses get bigger.
So I hope to get, well, after everything's all calibrated and pointing and straight, I can go and make sure my ROS works from last year, and then start improving it, the navigation on it. So the navigator is what slowed it, was making it really slow last year. So it could never beat in a match for speed. The ROS seemed to slow it down. I think I learned a lot on Robo Columbus, so hopefully I can make it better. Faster.
Yeah, I think the worst one of the connection issues I had was that when I worked at TI, they were only 8K by 8 memory and, you know, integrated circuit memories, and you know, all through hole. And instead of the pin going in the socket, it kind of curled. And so from the outside, it looked like, you know, it was in the socket and making connections and stuff. And so you know, it's like you'd shove this, and these were pretty big wire wrap panels, maybe, I don't know, like 1.5 feet by 1.5 feet. And, you know, hundreds of connections on each board, maybe even low thousands or something. Anyway, so you'd shove it in the rack, and it was like, and it was actually for a video display, you know, it's like parts of it would come up, and it's like, oh, ooh, wow, what's it, you know, why is it doing that? You know, and it's like, took me, you know, I think, I don't know, like 2 days to finally figure out that's what it was. And an 8K by 8 in like 82, they were pretty expensive back then. So I bought just enough for the board, and so, and I was actually able to bend the pin back without breaking it out, you know, off, and then getting it in there. But
how many 8K by 8s were there?
We've come a long way in memory. The first embedded computer I built used 256-bit by 4 memory chips.
Yep.
That was a long time ago.
Is that a core memory? Is that core memory or what?
Oh, it was static RAM.
Oh, okay.
I just remember having a couple rows of 14 holes of pins in my finger, my thumb, from pushing the memory chips into the RAM board on the PC.
Yeah.
Every once in a while, one would flip, and
I've been looking at upgrading my main Windows machine. I have a couple of 16 gig RAM machines here, and I'm thinking, so if I upgrade, is 16 gigabytes enough?
No.
Yeah, probably not nowadays.
I'm looking at motherboards that go up to 64 gigabytes.
That's a small amount these days.
Oh, I don't buy a laptop anymore because of what I'm doing. The current thing at work is 32 because that's what they're now buying it all. But if I buy it myself, it's got to have 64 gigs in it because I will be as a consultant. I fire up a VM for whatever client that I'm on. It gets a full 32 to do whatever I need to do on it. And then when I get done with it, I can assure the client I hit the delete button, or they can do whatever. You know, if they want to do special stuff on it or whatever it is, they can do whatever they want to that VM, and I'm messing with my host. But, you know, 16 gig gets it done most of the time, but every now and then when you got to have 6 Docker containers fired up and a bunch of other junk just to run the thing local, you need more, you know.
VMs are the reason that I run 64 on my machine, and when you got a couple of VMs running, you need the memory.
Yeah, it eats it up pretty quickly.
Oh, you poor guys who still have to work for a living.
I know, it's terrible. I just got a year closer to not having to do that, but I still got a little ways to go. So, you know.
Well, semi-retirement is still pretty good. Last year I managed to work just under half a year, and I'm aiming for the same thing, maybe just over half a year this year. We'll see how it goes. Well, guys, have we exhausted our robotics topics today?
I guess so. I was hoping to have more on my April tags, but I don't, unfortunately.
Yeah, there was another scheme that I wanted to explore, the kind of using video processing. If you have 2 lasers pointing out, you know, not quite straight, but just a little bit skewed, or even if you do have them straight, you know, pointing forward straight, pretty much any surface that they point on, if you have your camera tilted down a little bit, you can get the distance from that wall, because the point that's, say your robot's pointing at an angle towards the wall, the dot on the right will appear to be further up or a little bit higher, and you can get distance information from that, and should appear straight out, further off center, because it's a longer distance. So, but
Yeah, I think you could do that with one laser if you calibrated it correctly.
yeah.
If you use a line laser horizontally across the image,
Yep.
and your camera is essentially looking at an infrared or, you know, whatever color laser bandpass filter.
Yep.
You can pick up the laser line, and if you know the angle the camera is looking down, you can get all sorts of information out of that.
Yeah. But I thought, you know, and I actually just got some line lasers to kind of play around with them. But, you know, it's pretty simple to process 2 points.
Might be something pretty easy to try with one of these.
Oh, yeah. Yep.
You know, even at 5 frames a second, you'd be able to get some useful information.
Yep.
Out of it.
Yep.
I just thought I'd mention, I'm sitting here in the corner of my basement watching my outdoor security cameras since no one else is home. And I upgraded them all this past summer to high definition power over Ethernet cameras. They're all mounted out of doors, of course, We've had temperatures down to about -20 the last few weeks. Wind chills much lower than that. I don't know whether cameras are affected by wind chill or not. And I only paid about $21 or $22 Canadian each for these cameras. And I am just amazed. They look great. I would have thought the cold, I might have seen some problems, but they are working fine, just for reference.
Did you power them down and let them get to ambient and then turn them back on?
No, that would be crazy.
Okay.
But that's a good point. Good point, Mike. I don't want to do that experiment.
So I wonder, maybe
They
just,
only run about 150 milliamps to 12 volts, so there isn't much heat in there.
A lot.
yeah, there might be issues, I guess, with condensation, right? Or things freezing on condensating and freezing.
Yeah, so far not an issue at all, but
Oh,
there's
that's good.
packets of desiccant inside each of the cameras, but I don't know how well that works in the winter.
Oh yeah, and it may not last too long. A lot of those, once they absorb whatever moisture they can absorb, they don't absorb anymore. So
They absorb all the seawater they can coming across on a sea can.
yeah, God, what was it? Of course, I don't know the humidity, at least inside our house. It's like, I don't know, maybe 30% in the wintertime. So I don't, I'm assuming that's, I don't know if that applies, if it's 30% inside, is it 30% outside? Don't know. But it's pretty dry. So there might not be, no water to condensate on there. So
Yes, when you get in the neighborhood of hovering around the dew point, you start to see issues somewhere a little above freezing. But even with my old cameras, which were out there for probably 10 years, I never had any problems with that particular thing. I had issues of aging of the electronics, which caused the colors to start to change and the focus start to wander.
yeah, there was, I'm sure they don't have the resolution that yours do, but the, let's see if I can get to it. Telegram. I think it's it. You can.
No.
One.
No. I said no.
Oh, nope. Okay, it's got to be ESP Cam 2.
Somebody's being bad out there. I heard I said no.
Yeah, we have a bloodhound that we adopted, and we're babysitting. I don't know, she's kind of a mutt, but like a small terrier. And Red, the bloodhound, wants to play, and she'll come up and scare the crap out of the little dog. It's like, oh my God. But okay, I just took a photo. Let's see if it shows up. Okay, so there's a Telegram app, and I just took a photo with an ESP camera of the room. But they're certainly not, high res, but you can access it anywhere.
Finally pinned.
What's that?
Oh, it finally pinned your screen.
Oh, yep.
I clicked on it and it took a while.
Anyway, so yeah, I don't know if you can. It's a lot of glare, but
I
it shows
unpinned
the image.
it. We tried pinning it again. There it is. Oh, here.
Show it again, Ray.
Oh, okay. Let's see. I don't know if that's.
So what is it?
There's a camera. Oh, back over
Oh, okay.
here,
Ah, okay.
and a Telegram app. There was another one. Let's see. That one's actually pretty good. As far, yeah. Yeah, let's see if that one. Yeah, that's a much higher resolution image. That's in my living room. But so yeah, those are, it's got motion detection. It comes with all these goofy things like a free subscription to bird identification. It's kind of like has an intercom, a siren. You can turn on a light, take a snapshot. You can do cloud playback or TF card playback. So it's my wife's in there watching TV right now. So anyway, yeah, so that one is much higher resolution than the ESP cams I think ever could be. So
Yeah. I think my ESP32 cams are resolution wise are probably 1 megapixel, maybe 2 megapixels. But I don't know how well that translates when you are using them as a web camera server. I'm in the course of modifying the April tag test software I've got in order to add a local color display to it. So I have some idea what the camera is looking at, since it's hard to figure it out without having access to the camera signal.
Yep.
The April tag software uses both of the CPUs on the ESP32 to process, to do the data processing. So I'd rather not mess that up. So I'm not, otherwise you have to use a CPU for the web service, and I'm not going to do that.
I think somebody had an ESP cam playing video from a camera using a little SPI board. The SPI interface to a like a little LCD screen. And it was okay,
Yeah,
but it had to be a fairly small resolution screen.
yeah.
that's what I'm setting up, is a small SPI. You may recall that I did this when I was experimenting with the object recognition stuff on the ESP32 to recognize orange cones. And I had a local camera set up to show that image, and then overlaid it with the text data associated with the data processing parts. And I'm using the same electronics to build this test. And that's about all an ESP32 can do. That's kind of pushing it. The April tag software runs at about 5 or 6 interpretations per second. So that's not bad.
Yeah.
Seems to run reliably when I test it and get it running. And I can get all 6 of the data axes out of it, but they're just not calibrated well. 2 of them look perfect. The other 4 aren't there yet. So I'll recalibrate it and see what happens next.
Okay, I've got an update from our meeting on Saturday. Looking at May competitions 2026. I don't know if it's set in stone yet, but we're looking at quick trip, line following advanced, barrel racing, 6-can, a 4-square, and a sumo.
That
And
sounds
then,
like the list you put in your email, right?
that was the list in the email, yeah.
Right.
And then the November competition will be Robo Columbus again. And what else do I have? No Saturday.
I remember something about Canada and Dallas would be competing with each other instead of independent.
Yeah, so they're looking to, there's some rule changes they're contemplating. Nothing's been set in stone. So must complete 1 objective to get an award. So the idea is that, you know, if your robot just leaves the starting gate, it's not award winning. So it needs to complete, you know, at least one stage. So like Robo Columbus needs to make it inside the 10-foot circle around the cone. Then you'll get an award for that. If you're doing line following, well, you need to make it around the first curve before you can get an award for participation, that sort of thing. The other one is, and it's none of these are set in stone yet. They're just being considered. So limit of 2 robots per competitor per event. And that would try to allow for other people to make it. So if you enter 3 robots and you get first, second, and third, well, you would end up with first and second, and somebody, the fourth guy would end up with third place. And it's to help foster a little bit of competition and reward people a little bit for some of their trials. The other one, formalize a rule that a minimum of two competitors for the contest, for it to be considered a contest. So if there's only one competitor, it's not a contest, it's a demonstration. Otherwise, it's a demonstration. And then they talked about an exception if it's only one participant at a remote location, remote competition. So if we're out here, if I'm out here in Canada all alone doing something, well, I could win a prize for being the only one in a competition. We talked about that, and I also said that I would rather be judged with the group of competitors in Dallas. So, even if it means I come in 6th instead of 1st, it still lets me know where I stand with the group. And I think I'd rather be considered as part of the bigger group than a remote competition. So, but none of those have been formalized. We talked about some tech talk ideas for brainstorming. And so far, nothing for February for the monthly meeting. For the March meeting, they're talking about possibly the Comet Clash at UTD as an event to get and watch and see what's going on. Nothing for April. May, we have Roborama. And then November, we have Robo Columbus. We had a bunch of ideas. Mark presented a possibility of using a mod linker tool, I think he's working on, but that's not set in stone.
Yeah, I just need to, I'm working with someone else on trying to get some of the electronics up for it.
Yeah, so
once I have that, I'll be able to demo it.
I took a bunch of names out of the list I posted, so I didn't want to presume anyone was going to do anything, so I just put some ideas out there on the list I sent out. So maybe somebody can do a talk on CAN bus, STI, UART protocol. Possibly some ROS or ROS2 tutorials, how to set it up and communicate. We talked about watching somebody else's video at one of our things. So trying to remember his name. Is Andrew Spies or Spiels? I forget. He's the Swiss guy that does the robot videos.
Oh yeah. God, can't think of his name now.
I should have looked up his name, but I didn't get it. Anyways, he's got a video out about moving from vibe coding to AI next level. So basically bumping things up and getting it to work better, getting the most out of AI agents. Another one was an AI talk on using local versus cloud on a robot for object detection. So just an idea. And then KiCad or KiCad. Some guys really enjoyed the last time they did a demo on how to use it. So possibly an update or more in depth. 3D printing, modeling, design, structural, using software, different softwares, whatever, how to go about it, how to get things working and make things, straight, durable, resilient. Talked about a club robot, possibly reviving a club robot, and review an existing robot. If somebody has a robot that's doing something well, possibly having a talk on it Here's how it works. Here's what they've done to develop, you know, a sensor or an actuator or a gripper or whatever. Motor control scheme, something, anything about a robot. And then constructing robot simulation. So how can you go about simulating a robot? I know there's some tools in ROS you can use to simulate things, but there's other tools out there. So possibly use something like that. And then we talked about some opportunities. So one of them we've had in 2025, we had an issue with the website, DPRG.org. And it appears that there may be an issue running into memory problems in space, drive, that sort of thing. So it's a possibility of getting more space for the website.
Is the website hosted on someone's personally owned computer, or are you service?
It's hosted on a service that's donated to us.
Ah, got it.
And so it's very generous of them to donate the space so that we can run it, but we're running into constraints.
Mm-hmm.
So it's a possibility of getting more space.
Yeah, I think it's 64K. Yeah.
I was going to say, somebody hasn't cleaned out their email inbox.
Yeah. I can move up from the Timex Sinclair. So the other one was possibly restarting Robot Builders Night Out at the Dallas Makerspace. And somebody proposed every second Wednesday possibly for a get together locally in Dallas and have people go out there. Other one was getting Robbie the Robot, the big mascot, getting him working better. And so we talked about maybe articulating, both arms or something in the head and adding AI voice recognition, a bunch of different ideas about that. And then the other one was building a smaller robot for display because Robbie's pretty big to be hauling around. And so they talked about building like maybe a 4-foot version or something. So that was it. That was it from our annual meeting.
Did anybody see the debut of the Russian robots where pretty much the robot came out, took a few steps, fell over and started like flailing on the ground? They tried to pull a big black curtain out and cover it up, and maybe we should have a flailing robot demonstration or something. He could call him Russian robot.
Robot bloopers. Yeah.
Call him Vlad or something, But, yeah, there was another thing, you're talking about rewards for contests and stuff. Instead of like a participation trophy, it just, it's a little teeny trophy and it says, "I tried" on it, It's like, so
everybody gets a trophy.
Yeah, everybody gets one. So.
To do that needs to be a little blue flame and for letting the blue smoke out.
Yeah, maybe Doug could up his game instead of the just the clear plastic ones with letters or numbers or whatever etched on it. He could simulate a blue streak or something, burnt into the plastic maybe.
They also talked about standardizing the colors for some of the laser printed trophies.
Really?
Yeah.
Because
I think we just talked about the fact that there is no standard.
Yeah. There's been multiple different colors out over the years.
And nobody really cares. So, yeah.
I've got a pinkish and a yellow one on my shelf here. So.
I have an orange one and a yellow. Yeah.
I think all mine are clear. I guess that dates when I've won a contest last.
Tom had an orange one.
Yeah.
I was always thinking those would be pretty cool if you could light them from the bottom with some LEDs.
Yeah. Yeah, these are all clear. predates the color, I guess.
Yeah,
Well, I don't know. It's got a solid black base, but you know,
yeah, yeah.
They're black and
Looks like-
white.
They look like
Black and
tombstones.
white
black
case.
and white, right?
Well, guys, are we done with our topic?
Think so?
Oh, sure, I guess. Yeah, it's kind of nice, these calls. I mean, it saves me literally 2 hours in traffic to get to the Dallas Makerspace. So,
Yeah.
and usually, you know, the return is at 10:30 or 11 o'clock at night. And there's, I don't know if any of you guys are familiar with the roadways in Dallas. There's a bunch of toll roads, and one of them is the North Dallas Toll Road. And I was kind of on autopilot, and I was coming up to the North Dallas Toll Road exit and kind of just panicked and thought, oh God, I got to turn here, which I didn't have to turn. And so I got off, I had to loop around, find the next exit, come back, get back on 121, which is a Sam Rayburn, which is another toll road, and, make my little way home. So it's like, don't just drift off when you're driving and not think about where you're going.
My wife got asked to join a committee for the local garden club she belongs to. And the members on this little committee, they're scattered far and wide in the region. So she says, why don't we have a Zoom meeting? And these other members said, a what meeting? Because they had never literally ever been in a Zoom meeting.
Oh, wow.
So she got them all set up, and it turned out it worked really well for them. They love it.
Yeah.
My wife took a lot of Zoom meetings.
All right.
All right.
Good night.
Bye.
Good night, everybody.
See you guys.
Night, folks.